Hey everyone, in this video I am going to discuss and explain to you how to find the derivative of a trigonometric function, logarithmic function, exponential function, and a minima maxima problem. So in this video, I am assigned to create a problems regarding these 4 topics. And today, I will going to show you how do I solve these following functions and problems. Just to give you short information about the derivatives of trigonometric function, you need to take note that you have to memorize or at least familiarize this one. So the first problem that I prepared is function of x is equals to cosine square root of e to the power of x plus a over 5. Assume that a is a constant. In order to find the derivative of this function, we need to apply the differentiation rule for trigonometric function. The derivative of cosine is negative sine. Copy the inside and multiply it by the derivative of the inside function. Since the differentiation is linear at the inside function, you just need to pull out or separate the constant. In this equation, we need to pull out the 1/5 and find the derivative of the square root of e to the power of x plus a. Next step is we apply the power rule. We apply the power rule in finding the derivative of square root of e to the power of x plus a. We change the square root of e to the power of x plus a into exponential form. Therefore, it will going to be e to the power of x plus a to the power of 1/2. Since 1/2 is equivalent to square root. In applying the power rule, we take the exponent and multiply it to e to the power of x plus a, and its exponent is minus to 1. Therefore, it will be negative 1/2. After that, we will find the derivative of the inside, which is the e to the power of x plus a. In finding the derivative of e to the power of x plus a, we need to apply the exponential rule. E to the power of x, its derivative is also e to the power of x, and since a is constant, its derivative will always be 0. Lastly, we need to rewrite our solutions. Since we have a negative exponent, we will bring it down to our denominator to make it positive. For our final answer, you will have negative e to the power of x sine square root of e to the power of x plus a over 5 in our numerator, and in our denominator, we will have tan square root of e to the power of x plus a. So now we move on to the logarithmic function. You need to take note that in order to find the derivative of a logarithmic function, this picture right here will help you and guide you to find and solve the derivative of a given logarithmic function. The second problem that I have prepared is find the derivative of the logarithmic function. Function of x is equals to natural logarithm of tangent 3x over x plus 2. So the first step that we need to do in order to find the derivative of this logarithmic function is to apply the differentiation rule for the natural logarithm f of x equals to 1 over f of x multiplied by the derivative of f of x. So in this problem, what we're going to do is to reciprocal the numbers. The numerator will going to be the denominator, and the denominator will going to be the numerator, and we will be multiplying it by the derivative of tangent 3x over x plus 2. In order to find the derivative of tangent 3x over x plus 2, we're going to apply the quotient rule. We assume that tangent 3x is our f of x and x plus 2 is our g of x. You multiply the g of x to the derivative of f of x minus the derivative of g of x multiplied by f of x all over g of x squared. Since we have x plus 2 over tangent 3x, we will be multiplying it with the derivative of tangent 3x multiplied by x plus 2 minus the derivative of x plus 2 multiplied by tangent 3x all over x plus 2 squared. It is stated in our solution that we need to find the derivative for tangent 3x and the derivative for x plus 2. In order to find the derivative of tangent 3x, we will differentiate it using the trigonometric rules. So the derivative for tangent is secant squared. We copy the 3x and derive the inside. So therefore, we will be left with the derivative of 3x. The derivative for 3x is 3 multiplied by 1. Therefore, we will have 3. Since the differentiation is linear for the derivative of x plus 2, the derivative for x is 1 and copy the sign, which is plus. The derivative of 2, since it is constant, its derivative is 0. What we're going to do is to rewrite our solution. The x plus 2 squared will be put in the denominator together with tangent 3x. Since we have x plus 2 in our numerator and in our denominator, the exponent we have in our numerator will be minus to the exponent we have in our denominator. So since we have x plus 2 squared in our denominator, we will be minusing it to 1 and cancel out the x plus 2 we have in our numerator. Now we focus on our numerator. As you can see, we are left with secant squared 3x plus 6 minus tangent 3x. Tangent 3x came from the product of 1 times tangent 3x, and the 3x plus 6 is the product of 3 times x plus 2. Next we have in our numerator is that we distribute secant squared 3x to 3x plus 6, and for our denominator, we distribute x plus 2 to tangent 3x. So for our final answer, we will have 3x secant squared 3x plus 6 secant squared 3x minus tangent 3x all over x tangent 3x plus 2 tangent 3x. So now we move on to our next topic, which is the derivatives of exponential functions. In finding the derivative of exponential function, you have to take note of this one. For the third problem that I have prepared, we find the derivative of this exponential function. Function of x is equals to 4e to the power of 3x to the power of 2 all over sine 2x. First thing that we need to do is to check if we can simplify the given function. Since we have 3x to the power of 2, we can further simplify it. We have 9x squared. So for the given function, we will rewrite it as function of x is equals to 4e to the power of 9x squared all over sine 2x. So now that we're done simplifying the given function, as you can see in our equation, the differentiation is linear, therefore we pull out our constant, which is 4, and multiply it with the derivative of e to the power of 9x squared all over sine 2x. So now we are going to find the derivative for e to the power of 9x squared all over sine 2x. What we're going to do is to apply the quotient rule. So now we will have 4 multiplied by sine 2x, derivative of e to the power of 9x squared minus e to the power of 9x squared multiplied by the derivative of sine 2x all over sine 2x squared. In our solution, we will be solving for the derivative of e to the power of 9x squared and the derivative of sine 2x. We apply the differentiation rule for exponential function for the derivative of e to the power of 9x squared, and we'll be applying the differentiation rule for trigonometric function for the derivative of sine 2x. First, we solve the derivative of e to the power of 9x squared. First thing that we need to do is to copy the given exponential function, and we will be multiplying it by the derivative of its exponent. So in our given equation, we will have e to the power of 9x squared times the derivative of 9x squared. Next, we solve the derivative of sine 2x. The derivative for sine is cosine. Therefore, we will have cosine 2x multiplied by the derivative of 2x. Next step is we solve the derivative of 9x squared. The derivative of 9x squared is 9 multiplied by 2x. We will have 18x. And for the derivative of 2x, we will have 2 multiplied by the derivative of x, which is 1. 2 times 1 is 2. Another step is we multiply everything we have at the parentheses. So we will be multiplying sine 2x to e to the power of 9x squared and to 18x. And we will be also multiplying e to the power of 9x squared, cosine 2x, and 2. So our result is 18x e to the power of 9x squared sine 2x minus 2e to the power of 9x squared cosine 2x, and we will be distributing it to 4. Lastly, as we distribute 4, we will get the final answer 72x e to the power of 9x squared sine 2x minus 8e to the power of 9x squared cosine 2x all over sine 2x squared. So now that we're down to our last topic, which is the minima and maxima problem, there are steps that we should keep in mind. First is we draw a diagram if necessary. Second is we can write an equation representing the quantity to be maximized and minimized. We can use 2 or more variables to represent it. And number 3 is that we use any relationship between the variables to express the equation obtained in step 2 into a function of a single variable. And lastly, we differentiate it and equate it to 0. So for our fourth problem, a wire is 30 feet long and has to be formed into a rectangle. What dimension should the rectangle have to maximize the area? Remember the first step that we need to do in order to solve a minima-maxima problem. That is to draw a diagram if necessary. Therefore, I draw a straight line right there representing a 30 feet long wire. Since it is stated in the problem that it has to be formed into a rectangle, I have also drawn a rectangle. The question is, what dimension should the rectangle have to maximize the area? So we are looking for the area of the rectangle to be maximized. Therefore, we need the value of our length and our width. Therefore, we will denote our width as A and our length as B. In order for us to have a function of a single variable, we will provide another equation. We will be using a formula for finding the perimeter since we have a 30 feet long wire. The 30 feet long wire represents the perimeter of our rectangle. The formula of our perimeter is equal to 2 times length plus width. Therefore, we substitute the value of perimeter, which is the value of our wire, that is 30 feet long, equals to 2 times A plus B. Next is we divide both sides by 2 to cancel out the 2 we have at the right side. So we cancel it out. 30 divide 2 is equals to 15 equals to A plus B. For us to have a value of a function that has a single variable, we need to find the value of our B. In order to find the value of B, we transpose A to the other side. Therefore, we have B is equals to 15 minus A. Now we go back to the first equation that we have, which is the formula of area. Then what we're going to do is to substitute the value of B so that we have only single variable, which is A. So what we're going to do is area is equals to A times the value of B, which is 15 minus A. Next thing that we need to do is to multiply a to 15 minus a. The result that we will have is 15a minus a squared. For our fourth step, we need to differentiate the function and equate it to 0. Now we differentiate the value of our area, 15a minus a squared. As we find the derivative of our area, we get the value of 15 minus 2a. Then we will equate 15 minus 2a to 0. After that, we will transpose negative 2a to the other side to make it positive. We have 2a equals 15. What we're going to do to find the value of a is to divide both sides by 2. So now the value of a is 15 over 2 or 7.5. Now that we have the value of a, we will solve for the value of b. The formula for b is b is equals to 15 minus a. We just substitute for the value of a, 15 minus 7.5, so the value of b is equals to 7.5. Therefore, the dimension that we need to maximize the area is 7.5 by 7.5 feet. Since we have the same value for our length and width, therefore we have a square. So that's it for this video, guys. I hope that you learned something. Stay safe and God bless us all.